Scientists trying to unravel the mysteries of how our planet works and what could threaten its health are twice dependent upon NASA's Airborne Science program. Its use of more than a dozen piloted and unpiloted aircraft at 6 NASA centers and flight facilities supports and supplements the work of the agency's fleet of Earth-observing satellites.
We're the only civilian agency in the world that routinely flies above 50,000 feet.
The sensitive instrumentation used by a spacecraft to capture and measure what it sees below must be carefully calibrated to the highest standards. Airborne science aircraft are dedicated to ensure the sensor's accuracy and reliability.
We're looking at a whole series of new satellites in the Earth Science Division to launch. A lot of the sensors that will be on those satellites are right now being tested from our instrument incubator program on the aircraft. They're also testing the algorithm developments and how we're going to actually be able to utilize that data to help the society and the political policies that will be generated.
Once the satellite data are in, airborne science often delivers context and meaning, providing the whats and whys to Earth scientists. An airborne science aircraft can travel and linger in places where a satellite simply can't get one snapshot. The polar ice caps, a tropical storm on the equator, the eye of a hurricane. Returning with complementary sets of measurements, fresh atmospheric samples, and more detailed multi-dimensional imagery. Airborne Science focuses its aerial work in 6 areas of NASA's Earth Science Division: weather, climate, solid Earth, carbon cycle and ecosystems, water and energy cycles, and atmospheric composition.
In the atmospheric composition area, one of the things we looked at years ago with the ER2, which happens to be behind me right now, we were able to go into the ozone hole, and the satellites would tell us there was a problem with the ozone hole such that there was more ozone or less ozone at different times of the year. But we really didn't know what the numbers were.
Essentially, the ER2 aircraft was turned into a flying chemistry laboratory. Its ultra-sensitive instruments pinpointed chlorofluorocarbons as the ozone hole culprit and led directly to the Montreal Protocol. A recent report quantified how less healthful life on Earth would be without the 20-year-old international treaty banning CFCs.
They were saying in the report that it was 6 times the amount of ultraviolet radiation would be coming into areas like here in Washington, D.C.
As discussions continue to heat up over climate change and the health of our home planet, NASA's Airborne Science program will help provide facts for cooler heads to study. To learn more about NASA's Airborne Science program, log on to www.nasa.gov/missions.